So this is the Edge Connect orchestrator. So this is the sort of single web UI that we use to manage all of the Edge Connect appliances. Now, the way that you look at this, on the left side, this tree, these are all of the individual SD-WAN routers. This deployment here is a regionalized deployment. There are several different regions. As we kind of move around here, you can see there's a cluster of a large number of Edge Connect appliances in North America and Europe, all the way down into Asia and Australia. Each one of these regions has its own dedicated hub. We didn't talk about it, it wasn't on the agenda, but I do want to plug the fact that you can now automatically deploy an Edge Connect Cloud Hub into AWS by simply adding, add your account information, click the new EC deployment button. For those of us that have been handcrafting AWS instances and cloud routers for years, this has completely changed my life. I love it. It makes it so easy to stand up a regional on-ramp hub for a group of spokes. So we'll talk a little bit more about why this is important in a second, but I want to kind of talk through what all these green lines are. So without going into a long discussion around SD-WAN and all the different facets of it, fundamentally, the SD-WAN or the Edge Connect appliance creates IPsec tunnels to a large number of other endpoints. Typically, it'll create IPsec tunnels to other SD-WAN appliances. If you're in a hub and spoke topology, or in this case, a regional hub and spoke, the regional spokes will connect to the hubs connect to each other, and the hubs connect to other services. The spokes connect to other services such as, which I think we talked about today, Netscope, Zscaler, Checkpoint, Prisma, iBoss. We can do all of them. And the cool thing, so I personally manage this system. There's 102 appliances. This is sort of like my, it's just a small portion of my day, maybe a couple hours per week. A single operator or a single administrator can manage large number of individual spokes and branches using the automation that this kind of SD-WAN system provides. Let me show you some of what that means. So when we think about SASE and a lot of the story around software or web-based gateways, Zscaler, Netscope, these other guys, the hard part about that is how do you steer the traffic? How do you get the traffic to the provider? So the traditional way would be to stand up GRE tunnels, would be to set up manually craft IPsec tunnels, go make the settings on the router at your branch, then go make a bunch of settings on the Zscaler side and hope it works. Very time consuming and just rather challenging to do at scale. So what the Edge Connect does really well, and I can illustrate that here. I'm going to start with Zscaler because it's one of the first ones that we added, one of the first services that we orchestrated. And I won't go into great detail on what all this means and the different options and stuff that you have, but suffice it to say that when you add or when you provision a new Edge Connect or a new branch into your SD-WAN fabric, you say, do you want Zscaler coverage or not? And if you do, the system will go out, it'll find the closest Zscaler POPs, it will build the tunnels to them, and then it will create, importantly, IPSLA rules that ping through the tunnels all the way to the other side and verify that the Zscaler service is functioning, that the tunnel is functioning, that DPD hasn't malfunctioned, and that there's a real path to the internet through the Web Services Gateway Firewall. This sort of operational notion of building these tunnels and then making sure that they work is something we learned from experience. You can stand up a GRE tunnel or an IPsec tunnel, but it's very easy to get into a situation where you're black holing traffic into that tunnel because the other end of the tunnel doesn't lead to the internet. So we orchestrate and automatically create IPSLA pings or HTTP pings in this case that verify that the tunnel is up and that it's functioning. I personally think that yes, all the security stuff is great. It's good that I can bring to bear these Zscaler security capabilities on all of my traffic that's going to the internet. But if it's breaking customers' traffic, if my users are screaming at me because things are slow or not working correctly, it's not worth it. So we've done a good job of allowing you to bring in these security capabilities while verifying that we're not overtly impacting performance in the meantime. So the Zscaler, this is very, very mature. We have 100 or more customers that have Zscaler tunnels deployed hundreds at a time in some cases. In this case, we have 110 of them that are deployed here. But in addition to Zscaler, we also did Checkpoint, which I'm not going to demo today, but same thing. You add your Edge Connect appliance, your new branch to your SD-WAN fabric, and you say, do I want Checkpoint Harmony Connect coverage or not? But there are a number of vendors, and I want to talk about a little bit today. There are a number of vendors that either don't have an API yet, or they, for whatever reason, maybe the Silver Peak, we haven't integrated with them yet. It's a pretty long process. You have to, we go work with the vendor, you kind of rationalize how the API is going to work, you set up all these interactions, you do all this testing, and it's time consuming. So we built a system called the Service Orchestration subsystem that allows you to build any arbitrary automation to any service that you want. So in this case, we have several different ones provisioned here: Netscope, Prisma, Symantec, Akamai, iBoss. What you do is you add the new service, and then you create or import from a list that we have on our support site the definitions for that service. So in this case, we're looking at the Netscope definitions. So these are all of the Netscope POPs that Netscope has around the world. The endpoint, the IPsec endpoint for the POP, pre-shared key, and then a probe IP address. So this all we worked with Netscope, got this from them. So when you set up your tunnel, let's say you want to set up a tunnel to Amsterdam, and you want to send all your web traffic through Amsterdam to have them do the CASB stuff on it and filter and analyze and man in the middle of your HTTPS traffic and check it for bad content. For that Amsterdam location, we will set up an IPSLA rule that pings this destination. We'll also set up a second tunnel to Stockholm, so that if the Amsterdam tunnel IPSLA fails, the latency goes up too much, we will automatically take that tunnel out of service and start sending the traffic to Stockholm. So this is just a pointer to one of the other rows. For instance, I could trivially change this by like taking Mumbai and putting it right there in the backup remote field. So now for Amsterdam, anyone that's given Amsterdam as a Netscope POP, they will automatically be given the backup endpoint of Mumbai. Probably not what we would pick in real life. I'm going to hit cancel. But the point is, you can use this table to configure the endpoints, to configure the IPSLA and the backup. All of this can be done one time here in this endpoint UI. And then when you want to deploy it, or you want to connect a site up to, let's say I want to connect my East hubs to Netscope, I select the hubs in the tree, I go remote endpoint association, and I would say, all right, these are East Coast hubs. The Google, that guy's in Charleston. This Equinix data center here is in Reston. These are all Reston. So let's choose Ashburn. So we do that, and then we would hit save. Now, what will happen is the Silver Peak will go out. You'll notice that it starts, this little flashing blue thing here is going to give you a time. It's going to let you know how long it's got left to orchestrate those tunnels. So it's going to go create and configure IPsec tunnels to Reston and the backup for Reston, I think, which was Atlanta. Build that, create that for you, and make it accessible to our policy engine. Let me talk about that part. So once you build the tunnels, once you have this, you say, I want to send my web traffic to a CASB like Netscope, or I want to send my all of my traffic to Zscaler. You might say, how do I get that traffic into the tunnel? What does the steering mechanism look like? And in the Edge Connect, this mechanism manifests as a business intent overlay. So I'm going to click this little tab here, and you'll see this somewhat busy table. Try not to let it overwhelm you too much. It's actually, this is the heart of SD-WAN, at least the heart of the Aruba Edge Connect SD-WAN. Each one of these rows here is like a layer. So packets or flows come into the top, and they start falling down through, they start guest, they're going to try to match on the guest overlay first, then they'll go real time, CASB, batch, all the way down to the bottom. If none of these match, none of the top 6 match, then the traffic will automatically hit the unclassified overlay. So each one of these rows here is called an overlay, and it has a bunch of different characteristics that tell the system how to treat traffic that is matched into that overlay. So one of the important characteristics of how you configure an overlay is you tell it, if the traffic is destined for an internet IP, what do you want me to do with it? Do I backhaul it to an AWS or an Equinix on-ramp? Do I break it out locally? In other words, do I NAT into the local IP address of my service provider? Do I take that traffic and put it into a Zscaler tunnel and send it over there? Do I send it to Netscope? Lots of different options available. And in fact, I've got to plug this because we had this little snafu earlier, this little outage. They didn't have a Silverpeak SD-WAN probably, because one of the cool things you can do, for instance, here at my house in Kennesaw, Georgia, I'm in Atlanta, actually, North Atlanta. I am blessed to have 3 different, we call underlays, or 3 different WAN side connectivity mechanisms. I have a Verizon LTE, which serves as backup, and then I have 2 high speeds, a Comcast and an AT&T fiber connection. These are called underlays, and we assign one of these things called a label to each one of the underlays. So for me, my Comcast connection is INET B, my AT&T is INET A, and my Verizon connection is LTE A. The labels are a generic mechanism that says, I don't need to know that it's Comcast or AT&T, just it's an internet and it's either A, B, or C. So for me here, my voice right now, when I talk to you guys, my video and my screen sharing, this traffic is leaving my house. It's going across both INET A and B simultaneously. It's being backhauled to AWS, to Reston, and then it gets NATed via an elastic IP out to the internet. Now, the cool thing about that is that if I reach over and unplug, if I go to the garage and unplug my Comcast connection, or if I unplug my AT&T connection, I can just pull the box right out of the wall. Nothing happens. You wouldn't even notice it, because the way the Silverpeak works, one of the characteristics you can use for the overlay is called high availability mode. So here you see the real-time overlay has. You see it talks about how to treat traffic that goes across the fabric. The high availability mechanism says for everything I say, send that traffic 2 times. Send it both. Send the primary packet over AT&T or whichever one's faster, and then send a copy of that packet over the second best link. So when we talk about first mile ruggedization and the idea that the last or first mile, depending on how you look at it, is normally the fault place.
I have a question if you don't mind.
That's usually it. Yes, sir.
I was just wondering about the SLA. Is that from the public facing interface to the other one, or is that through the IPsec tunnel?
So we do a bunch of different IP SLAs for the services like Zscaler and Netscope. We ping through the tunnel. So we orchestrate, everything is automated and orchestrated. We really frown upon we call snowflakes. Individual settings you would do on a certain appliance are frowned on. So when you add an appliance to the system, it is automatically given a loopback IP address from a loopback pool, and then that loopback is the source of the IPSLA pings that are sent through the IPsec tunnel to a designated endpoint on the other side of the tunnel. Now in Zscaler's case, they have a special endpoint that they provide. So they want you to use gateway.zscaler3. Gateway. Whatever your tenant is, because this can vary, /VPN test, and they will respond with an OK, 200 OK. That's it. If we get back an OK, and our running average over 300 seconds is less than 500 milliseconds, and our average loss is less than 10%, then we will deem that Zscaler tunnel as ready, as in service. If the loss or latency climbs, or if the tunnel is just down, the IPSLA events fail, then the tunnel will be taken out of service, and the Silverpeak will fall down to the next tunnel in line. Hopefully that answers it. So there are other types of IPSLAs we do. For instance, for just, let's say that I don't want to go through Zscaler. I just want to go straight to the internet via my AT&T connection. Then the Silver Peak pings from the AT&T public IP, with the AT&T IP that the Edge Connect has at the site to whatever endpoints you designate. Silver Peak offers a globally accelerated AWS endpoint called sp-ipsla.silverpeak.cloud. Most people will ping to that endpoint, and you can add a second endpoint to ping as well. So we're very much into automated IPSLA rules that check and verify that all these different paths that you might send flows across, verify that they're functioning and that they're performing at the level that you would expect.
Yeah, because one of the things that I would really appreciate is if you have an application and you can actually verify that it has a certain characteristic profile going across, one of each tunnel, and do some dynamic routing based on that.
Yes. So we typically think of the 0000 performance. So we think of what is the performance to the internet. We don't have as much knowledge or as much care about specific applications. You can set up an IPSLA to monitor a specific app or monitor to a specific endpoint, but we sort of generalize it and say the internet itself, the 0000 route, is accessible, but you can further narrow it down to specific applications if you choose to. So all of this is about allowing the customer to choose. And you can kind of see, let me go back to the business intent overlays here. You can see, I never did get to it, I'm going to now. Notice the little icon here. It says Netscope. We've got Checkpoint appears down here. We've got Zscaler up here so we're literally invoking three different, whether the customer chooses to do this, don't know, but they certainly have the ability. They could transition. They could be like, I have Checkpoint today and I want to migrate to Zscaler. You can have them both at the same time, both of them in flight. The way this works though is any traffic that hits the guest overlay here. So if I connect to a guest port, that will go to Zscaler. Any traffic that hits my CASB overlay will go to Netscope. Down here for the business overlay, the default behavior is to break out locally. But let's say that something happens and my local breakout pings are failing for whatever reason, then it will fall down to the next, whatever's next in line. And this is actually the cool part. This is what I want to mention. The hubs, so let's say that all of your tunnels are down to Netscope at one of your branches. What do? So if you look at what the policy says here, it says Netscope is a first choice. The second choice will be backhaul. Now, what does that mean? Well, it means if the Netscope tunnels are unavailable or if they're experiencing high loss or high latency, then the Silver Peak will say, all right, the Netscope tunnels are no longer eligible. What's the next best path to send these packets or these flows? And then it'll look in this policy and say, oh, it's backhaul. So now it will go and look in its routing table and it will see that, the best route I have through the fabric, protected across the fabric to a data center and then to the internet, is in our case in the East Coast, East 2-AWS. So basically the traffic will route from the branch to the hub and then hop on a tunnel and go to Netscope. So you can't escape. Like if you were to down the tunnels to Zscaler or Netscope at the branch, it doesn't matter. The traffic will just adapt and go to the nearest hub, and at the hub do a hairpin, a WAN-to-WAN hairpin, hop in the tunnel to Netscope and go from that way. And then of course, if the hub is, let's say the hub's tunnels are all down to Netscope, then the hub has its own policy. So that it would say, well, what do you want to do at the hub? Do you want to break out? Do you want to backhaul if the tunnels are down? So you have this sort of flexibility and resiliency of being able to define how the traffic is steered toward the internet at a very granular level. What we are doing, so all of this I'm talking about so far, this is all stuff that's on the truck. We've had this for quite some time. The service orchestration, the ability to add all of these arbitrary integrations like this is new. This is in the 905 orchestrator release. But one of the other new things that David Hughes and Rolf talked about a little bit was our integration with ClearPass, and more generically, our integration with identity context. So for the first time, we are bringing username and role context-sensitive information into the Edge Connect, into what you see here, into this experience, and in phase one, in this release, I'm going to show you here, we are going to be displaying the username information, displaying the information alongside all of our other stuff. So basically the orchestrator here, this system you're looking at, this is a cloud orc. It's running in, it's hosted by Silver Peak. It is connected to a AWS-based ClearPass. And when devices authenticate with ClearPass, ClearPass sends, it has an external context server configuration. It sends that login, logout information to the orchestrator. So that's what you're seeing here. So this is like the tracker that ClearPass has. This is like a mini version of that. Just a very simple list of IP address to username mappings. Ultimately, that's what this is about. It's empowering the Edge Connect and the policy engine that we provide with knowledge of IP address to username mappings. Now, once this information is in the system, we have all kinds of stuff we can do with it. For instance, one of the obvious, for people like me that have been using this system for a long time, I have always wanted to be able to know not just what the IP address of an endpoint is, but who the users are. So this is called the flow table. And for people that have worked with the Silver Peak system, or the Edge Connect, Aruba Edge Connect system before, you would know that this is arguably one of the nerdiest but most valuable panels or most valuable reports in the product. It is a real-time display of the flows of the individual sockets that are present on the network. And this one right here in particular, this is me talking to you right now. So you can see I've 28, it's actually quite surprising how well Zoom does with compression and whatnot. 28 meg over the last 5 minutes. Adam Powers is the user that's referenced in this flow. It's Zoom. And we actually, if we look closely, we'll see that this flow is backhauling to East2-AWS over the real-time overlay. So this is a protected flow. So this flow is not going to Netscope or Zscaler. It's going straight to AWS and then straight onto the global backbone and onto Zoom. But what we've added in this initial release is the fusion of network telemetry information about how the network is functioning with the usernames and roles. Now, without stealing too much of my thunder for like 6 months from now or whenever this happens, the next phase is to use this username information in the policy mechanism that the Silver Peak provides. So today, when we define, let's go look real quick. When we define, let's look at CASB here. So the CASB overlay has a little thing at the top up here, a match filter. So it's just saying, what traffic do you want to send to the CASB overlay, or to Netscope in this case? And so you click this little edit button, and you can see here that we're saying Salesforce, Atlassian, Confluence, and Jira, and then Smartsheet. These are the three I want to send to Netscope. In the future, you'll be able to match based on the username. So you would say, if the role is X employee contractor, then send those folks to the CASB destination. Or if the if the user is Y, don't send them. Or if it's an executive user, backhaul them and protect them to AWS. Don't send them to Netscope. All of these choices, the ability to sort of say, I am going to look at the role and the username and give special treatment or special steering or other inspection. I can bring the Silver Peak I can bring the SD-WAN functionality to bear on the usernames and the roles. So it's exciting for me because I've never, as an old school network guy, I've never really had a situation where I could work in the context of identity information and make actual routing decisions based on users and roles. Yes, sir.
Yeah, I got a quick question. Just on the V6 side.
Yep.
So if you've got a site that's an edge site that's got V6 enabled, but you don't have V6 as an end-to-end component, how are you guys making a determination about whether that client should do breakout, not breakout, use V6, not use V6?
Yeah. So
pipe it over as a tunnel overlay, et cetera.
Yeah. So currently we don't do breakout for V6. So like if they had, who we're looking at here, imagine I had a V6 subnet on the LAN side here. So this is the LAN side, this is the WAN side, and you could have, v4 landside subnets, v6. That v6 subnet, the Silver Peak could not facilitate access to the internet from that v6, not natively. So our breakout mechanism only, the policy mechanism only takes into account v4 breakout. So this is when people talk about, like you have partial support for v6 and there's certain things that we need to do. That's a good example. However, you can do this. I can add an interface and flip that thing to v6 right there. You see, it'll do DHCP v6. It'll pick up an IP address. You can dual home, have two interfaces physically plugged into your AT&T cable modem or your AT&T Vrfs modem, and one will get v4 and one will get v6, and there'll be two different underlays that are formed, and they're redundant for each other, which is
so you can
cool.
only use it as an underlay. You can't.
Yeah.
It does not allow any of the local client access to use v6 at all. So you're not going to pass v6 to the LAN side, is what you're saying.
It'll route directly through the box. So if you just want to do straight up what we call pass-through routing, like traditional routing, but the policy-driven stuff, like where if it's destined for the internet, then I want to put it on INET A or B, we haven't done that yet.
Okay, and then if you've got multiple providers and you're getting different global unicast address spaces from each provider, are you passing both of those through to the LAN interface side? In which case, every host is getting.
We are not yet.
Okay.
We are not yet. Yeah. So there are some gaps. The current product kind of assumes that you might do. It's organized around this use case, the dual stacking. So I'm got a v4 and a v6. We've got work to do though, and like I mentioned before, we are adding all of it. VRP and BGP are the next two big ones, but there's a lot. V6 is for all the vendors, it's a significant effort in many different ways. So yes, we're finally seeing it. I want to talk a little bit about this zone-based firewall and one of the new features that's coming that I'm actually have to use a different system to show. So Rolf mentioned this, but I want to further discuss it because it's really powerful. So when you think about the Silver Peaks, and we built this, right? This is all native. We did not license someone else's firewall or anything like that. We built an integrated end-to-end zone-based firewall. And when I say end-to-end, that means literally when a packet comes in on the LAN side of one of my branches, let's say that I send a packet that arrives on Kennesaw 3, LAN 0. At that point in time, the Silver Peak already knows, based on the destination IP, where it's going to come out, what zone it's going to exit the fabric on the other end. So the best way to think about the Silver Peak zone-based firewall is that it's like a gigantic logical firewall that has hundreds or thousands of interfaces connected to it. There's not, so this matrix that you see here, this is a global matrix. You can go and make exceptions and make specific policy adjustments per branch, per site, but the recommendation and the best practice is you have a single zone intersection matrix like this that is deployed to all appliances everywhere simultaneously. So it means you only really have to manage one intersection. But when you say, so if traffic comes in from trusted, now the from means stateful. It means like a TCP SYN left the client, that's what the from means, to would be the server side of the flow. So this right here means from trusted to trusted, we're allowing that traffic. Now the other end, the to trusted, that could be 1,000 miles away on a different appliance in a different region on a hub in AWS. The local branch, Kennesaw 3 in this case, knows how to make that policy decision, how to deny or accept that flow ahead of time before the packet gets to the other end. So it makes building and deploying policy rules for firewalls on a very large scale much easier when you think about it in terms of this single logical matrix of an intersection of policy sets. This is taken to another level by a new feature that I'm going to show you. This is not in the 905 release I was just showing. This is a little further out. So we have added intrusion detection subsystem. Rolf talked about it a little bit. Basically, you say, all right, do I want to I enable or disable the intrusion detection mechanism per appliance. It's also licensed per appliance. And then you tell the system how you want to, what you want to inspect using the same kind of zone-based firewall mechanism, only we've infused it with intrusion detection is a way of thinking about it. So like here we've got, we're looking at a smaller deployment of the smaller set of zones. Here's an example: from trusted to untrusted. I'm denying all adult sites and I'm inspecting everything else. So inspect here means allow plus inspect. So allow is allow the traffic, but don't send it to the intrusion detection system for analysis. Deny just means deny, and inspect means allow the traffic and shunt it or send it to the intrusion detection analysis subsystem on the local appliance for inspection. So you have. Yep.
Can I ask a question?
Yes, sir.
Is it detection or prevention? So
It's
is
detection
it
in
dropping
this
it
release.
inline?
Yes, in this release it is detection. So a little bit like the with the username and identity. So in phase one, we're showing the usernames, we're represent them in the UI. We're making sure that we can successfully and accurately bind IP addresses to users. We're going to let that be in the product for a while and verify that that works and does what we want it to. And then as phase two, we'll push the usernames into the policy engine and allow actual packets to be manipulated by the presence or absence of users and roles. Intrusion detection, we're handling the same kind of way. The initial release that's coming soon is inspection only. So it will kick out, I don't know if I've got a, yeah, I do. So it'll kick out eve.json events or fast.log events. What is it? Unity 2, or it'll kick out events to Splunk or your favorite log aggregation system, but it is only intrusion detection, at least initially. Now, the next time we talk, certainly by the next network field day, this will probably be a different story. We will have added the active, the loop to come back around and invoke an action on the traffic by this time next year, most likely. But in the current release, it is inspection only. But again, the takeaway what I wanted you guys to take away from that is that this notion of right-sizing inspection, so inspecting just the things that are necessary, because if you think about it, at least in this system that I was just showing, Zscaler or Netscope or these other guys, they're doing inspection for north-south traffic. When I say north-south, talking about like stuff from the LAN side of a branch to the internet. They're doing that inspection. Do we need to inspect it twice? You can certainly set that up. That would be from default to untrusted. So from trusted to untrusted. We actually are already inspecting in this case. But more generally speaking, this fusion of the intrusion detection and eventually prevention system with the zone-based firewall, with this matrix, provides a level of flexibility that I don't think is common. I think this is kind of unique for the Silver Peak. And then so if you add usernames on top of it, so you'll also be able to match by users and roles in this screen. So now you can say, I want my let's say contractor role to always be inspected. You could build a rule that does that. Say inspect all my contractors, but don't send employee traffic to the intrusion detection system. Just let that stuff pass through and go local breakout straight to the internet. All of these different policy mandates and decisions, the Edge Connect can bring to bear rather easily because of the flexibility of the way the overlays and the zones and all of that comes together. I haven't even talked about VRFs and segmentation, coarse grain segmentation. We also added that recently. You can do VRFs. You can have as many as you want. VRFs are also globalized. So actually, if you notice here, there's a segment or VRF called IoT. The IoT segment has its own specific set of zone-based firewall matrices or intersections that can be configured. So you have steering, segmentation, identity context, firewalling multiple layers of firewall. So it's, and on top of all that, that's the security stuff. On top of all that, it's still SD-WAN. It's about performance. If I pull one of my 2 internet connections out of the wall in the garage, then my traffic doesn't stop. I can still talk to people. Ultimately, SD-WAN started in performance, to making things go faster, making things more reliable. We still do that, but over the last few years, we've added a great deal more security to that story or to that capability without sacrificing performance and availability. And I think that's a big part of what makes us different, at least from a practitioner standpoint that doesn't so much think of the message and the mark and all that. From the real day-to-day operational aspect, I really like the fact that we've focused and we've kept our eye on performance and availability and robustness of these large networks. We have a bunch of them. We have a lot of big customers, a lot of big production accounts that use this stuff. So we have to be very careful what kind of security things we bring to bear, such that we don't make them mad. I am increasingly getting SEs and sales teams that ask about IPv6. It is finally becoming a determining factor in deals, in opportunities for the Edge Connect product. We've been able to dual stack on the WAN side for a long time. So you can form a V4 tunnel and a V6 tunnel for your AT&T modem and have 2 different paths, if you will, across the internet using both. You actually get different latencies and a different performance curve for V4 versus V6 sometimes. But what we're starting to see more so is that people are wanting V6 on the LAN side, like in the spoke or in the branch. And we're adding VRP and OSPF and BGP support for V6 relatively soon. So I think it's increasing more so in the PAC rim, not as much in North America.
Yeah, it's good to hear that support's being worked on, because I know that that's definitely becoming a deal breaker for a lot of things to support the latest versions, because it is very important, especially on the LAN side. So
that's what it needed, though. It needed to become a deal breaker, and there are a number of large customers that are making it a deal breaker, and the vendors, I think, will finally decide to commit what's necessary. There's a lot. There's a lot that goes into V6, and sometimes from a PM standpoint, it's a little hard to see how it's going to be used in the real world, because not as many folks seem to need it.